Hello. In the last video, I promised to you that I will come up with a video on Euclid's division algorithm. And here it is. This video is going to talk about Euclid's division algorithm, what exactly is it and where it is used. And we are also going to learn it with the help of some common examples that are used in everyday life. So stick around till the end of the video and let's dive into it straight away. Welcome back. So I told you that this video is about Euclid's division algorithm and I'm going to explain to you in very simple steps as to what exactly Euclid's division algorithm is. Where is it used in our daily life? Is it really used or not? And we are not going to learn just the theory part about Euclid's division algorithm. We are going to learn exactly looking at some proper everyday examples about where is it exactly used, and we are going to have a pictorial representation also. Now I have done a live stream on Euclid's division lemma and Euclid's division algorithm. I had done it on my channel last week, and if you happen to miss that video, it is linked in the top right corner of the screen. Just click there and have a look at that. Now for the purpose of this video, I am going to take some excerpts out of the live stream and I am going to put it in here. I'm sure you will understand it in a very simple way, and in the end after the live stream I will explain to you properly in a visual manner about how Euclid's division lemma is used. So basically I'm going to gradually come on to Euclid's division algorithm now. So let us understand that what the lemma is used to prove. The proof is that it is basically used to find the HCF of two numbers. So let me write the general formula of Euclid's division lemma, which is A is equal to BQ plus R. If we want to find the HCF of A and B, HCF of A and B, then to find that we can write A is equal to BQ plus R. Now there are two possible cases, that R will either be 0, that means there is no remainder, or it will leave some remainder. Now if it leaves some remainder, what you can do is you can just bring this B number here, so we'll get it here, B is equal to, and you can get R here, so we'll get RQ plus R1. Because if you find if R is the remainder, then if you just find the HCF of B and R, and that will be the HCF for A and B as well. So let's understand. So in case R1 is again not 0, we'll again bring R here, find the HCF of R. We can write R as R1Q plus Rn. So this will keep continuing till we get Rn is equal to 0, and when Rn is 0 we can take the divisor and say that that is the HCF, and HCF not only for B and R, it's going to be for A and B as well. Now let us understand with the help of an example and HCF of 30 and 48. So like I'll first show you how I explained it to you, that basically we have to find HCF of 30 and 48. So we'll write it in the form A is equal to BQ plus R, where A is always the larger number of the two. So I'm going to write it that 48 can be written as 30. It has to be divided by 30. Now 48 and 30 are fixed in this case, and it has a unique quotient and a unique remainder. So what is the quotient going to be? So 30 times 1 is 30, 30 times 2 is 60, which is going to be more than 48. So it is only going to be 30 times 1, which is 30, plus how much remainder does it leave? 18. Now since I told you that if the remainder is 0, then we can say that the divisor is the HCF. So in this case HCF is not equal to 30 because the remainder is not 0. So the next step is that you have to bring this number here. You can write 30 is equal to, bring the 18 down here. So 18 times how much is 30? 18 times 1 is 18. 18 times 2 is 36, which is more than 30. So obviously we can't take it 2 times, it has to be 1, plus it leaves the remainder of 12. Now again 12 is not 0, we bring 18 here. So here now we were finding out the HCF of 30 and 18. In this case, you bring 18 here. 18 can be written as 12 times something. So here we are trying to find out the HCF of 18 and 12. So 18 is equal to 12 times 1 is 12, 12 times 2 is 24, which is more than 18. So I can write it as 12 times 1 plus it leaves a remainder of 6. Now again 6 is not 0, so I'll have to continue, I'll have to go a step further. So I bring the 12 here, I bring the 6 down here. So 12 can be written as 6 times something. So here we are trying to find the HCF of 12 and 6. So 12 can be written as 6 times 2 plus 0. So because we have got the remainder as 0, we stop here and we say that this divisor is the HCF. So we can say that HCF is 6. HCF of this also is 6, of this also is 6, if this also is 6, and of this also is 6. So we can write that the HCF of 30 and 48 is 6. Now tell me, are you much clearer with this example or not? Do you understand how Euclid's division lemma is going to be used? Or this is an introduction to the Euclid's division algorithm now. Euclid's division algorithm, like I told you what is the concept behind it. So algorithm, if I talk about algorithm is nothing but a set of steps or a set of rules that must be followed when you are solving a particular problem. So I'll give you a very simple example of like when you make tea. What happens when you make tea? So when you're making tea, what you have to do is you have to take some water and some milk. So usually you take about 80% water and 20% milk. So you add some water and milk, bring it to a boil, and once it comes to a boil, you add some grated ginger in it, so get a nice flavor, and you add the tea leaves. Let it simmer down for about 10-15 minutes so that you get a nice wonderful aromatic flavor out of the tea. And once you get that, then you just bring it to a boil again, switch off the gas and pour it into cups and add sugar to your taste. So that is the algorithm for making tea. Now similarly, there's an algorithm or a recipe for everything. So if we understand the recipe for this, for division, we'll understand how we can solve a particular problem. So the steps that are involved in this are that we apply the Euclid's division lemma to the numbers and write them in the form A is equal to BQ plus R, where I told you that A is the greater number out of the two and B is the smaller number. So it can always be written in the form BQ plus R. R is greater than or equal to 0, but it is less than B. Second step is that R is equal to 0 and the HCF is B. That's sure. B is the smaller number. Or if R is not equal to 0, you have to apply the Euclid's division lemma to B and R, where you write it in the form B is equal to RQ plus some remainder, which let's call it Rn. Now there are two possibilities. If Rn is 0, then R is the HCF, or if Rn is not equal to 0, you go back to step 2 and keep doing it, keep repeating the step until you get Rn is equal to 0. When Rn becomes 0, then whatever R was there in the end, that is going to be the HCF. Okay, let's have a look at a couple of real life applications also. Mason has to fit a bathroom floor with square marble tiles with largest possible size. The size of the bathroom floor is 17.5 feet by 12.5 feet. What will be the side length of each tile in inches? So again, these are square tiles, so that means the length and breadth will be the same. So we have to find the side length of each tile, and in inches, that's the important part. That means the 17.5 feet, we'll have to convert it into inches, and the 12.5 feet, again we'll have to convert it into inches. So to convert it into inches, we first have to know how many inches are there in 1 feet. 1 foot consists of 12 inches, so obviously we'll have to multiply it by 12. So 17.5 multiplied by 12 and 12.5 multiplied by 12, so 210 inches. And the breadth of the floor is 12.5 multiplied by 12, so 150 inches. So basically we now have to find the HCF of 210 and 150. So again, let's write it in the form A is equal to BQ plus R. So 210 can be written as 150 times 2 will be 300. So obviously it has to be 150 times 1 plus it leaves a remainder of 60. 60 is not 0. We'll have to continue. 150 comes here. That will be equal to 60 comes here. 60 times 2 will be 120 plus it leaves a remainder of 30. Now again we have not got the remainder as 0, so we'll have to continue. 60 comes here, 60 will then be equal to 30 comes here, 30 times 2 which is 60 plus it leaves a remainder of 0, and now because the remainder is 0, this is the HCF. So the HCF of this and this is 30. So each tile should have a side length of 30 inches. Side length is equal to 30 inches. Now tell me, if you actually meet a mason and ask him what Euclid's division algorithm is, would he be able to tell you what it is? Probably not. I have my serious doubts. But if you ask him what is going to be the size of each tile that will fit exactly in this room, he'll not only tell you the size of each tile, he'll also be able to tell you the number of tiles that would be required to fit in the room. But how does he do it? I'll tell you how does he do it. He does it out of experience. He does it out of hit and trial method. He doesn't know how to calculate the HCF. But we educated people that we are, we know what Euclid's division lemma is, and let's apply the same problem. How does a mason does it in his mind that we are doing here. Now let's do this question visually also and let's see the same size of the room that we have here. So let's say that the length of the room as we calculated is 210 inches and the breadth of the room is 150 inches. Now what we have to do is we have to cut the room open in squares. So we have to visually mark a square. So let's take a line like this, and so we have one square. Now if you look at the top side, we have got two sides. So this side is 150 inches and this one on the right is 60 inches. So we have got a full square having a side length of 150 inches, and we have got a rectangle which now has a breadth of 60 inches and a length of 150 inches. Now we'll try and make squares in this rectangle also. We are going to focus only on the rectangle. So let's mark a square here. Now we are having one square having a side of 60 inches and we've got a rectangle. But looking at this rectangle, I think we'll be able to fit in another square into it. So let's try and fit another square. So now you see that we've got two squares fitted into it, and what we are left with is two squares and a small rectangle at the bottom. Now these squares have a side length of 60 inches and the rectangle at the bottom has a length of 60 inches and a breadth of 30 inches. Now let's divide this also into squares, and I think we just need one line here so that we have got two squares each having a side length of 30 inches. Now since both the squares are equal and we are not left with any rectangle to play around with, so we know that this is the size of the tile that we need, and we can fit these tiles in the rest of the room just like this. Right, so we learned that Euclid's division algorithm is used to calculate the HCF of two or more numbers. Now that is not the only way of finding out the HCF. There is another way also, and that way is called the fundamental theorem of arithmetic. And if you want to learn all about it, just click on the video appearing on the screen right now. Now do not forget to click on my picture here, because that is going to get you subscribed to the channel and any future videos will be intimated right into your inbox. And do watch these videos appearing on the screen because they are going to be very helpful for you. And before going, why don't you just click on the like button too? I like it. Thank you. Take care. God bless.